So, welcome students and welcome to What is a Log Anyway? So log, you've seen on my board all year probably that there's something called a logarithmic function. So log is short for logarithm, and there's a pronunciation logarithm. But what is it? So that's what we're going to find out today, just what is a log. So let's see, there's lots of different types of equations involving exponents that you know how to solve. So if you have, for instance, zoom in, if you have something like x squared equals 100, you know how to solve that. The inverse, you're just going to take the inverse of squaring, which is the square root. You're going to square root both sides, plus minus square root, which gives you x is 10 or negative 10. So you know how to do that. What about something like x to the power of 3 over 2 equals 8? Well, in this case, you guys know you have to take the reciprocal of the exponent. So we would have x to the power of 3 over 2, and the reciprocal is 2/3. And we know that those exponents cancel because they're inverses. So that gives you x equals, and if you put this in your calculator, you get 4. So you know how to do that. So you know what to do to find x when it's raised to a certain power. You even know what to do in a case like this, where I have 2 to some power equals 8. Because I know that 2 times 2 times 2 is 8, and that's 2 to the third. So 2 to the x, well, it's really 2 to the third, so x is 3. So all those types of equations that involve exponents in some way, you already know how to solve. Now, what about this one? 2 to the x power equals 10. So what on earth is the inverse of 2 to the x power? So I know that, for instance, 2 to the third, I know that's 8. And 2 to the fourth is 16. So notice we have skipped 10 entirely. Like, it's not there. It's not 2 to a whole number power. That means x must be some kind of decimal. But how do I know what decimal it is? I mean, if I try my other methods, like if I try the reciprocal method, for instance, I could do 2 to the x and then raise it to the reciprocal, which is 1 over x, and then 10 to the 1 over x. That leaves me with 2 equals 10 to the 1 over, that should be an x. Wow. That leaves me with 2 equals 10 to the power of 1 over x. Has that helped me at all? I mean, I got rid of this x, sure, but now it's over here, and now it's in a denominator of a fraction, so I've actually made things a little bit worse. So something like this you haven't learned how to solve yet. But not for long, because that's what you're learning today. And the answer to this question is a logarithm. So today we're going to concentrate on just what is a logarithm and how can you use it to solve a relatively simple looking equation like that without losing your mind and ending up with something like this, which makes no sense. So a logarithm is how you cancel out an exponent of x, so they're inverses. So like something like 10 to the x power, its inverse is going to be a logarithm. And logarithms actually are used quite a bit in science for interest. So interest rates, figuring out if you're trying to save, $500,000 for your retirement, how long is it going to take you? A logarithm can show you that. Bacterial growth. How long is it going to take the bacteria to reach a critical stage where maybe they overwhelm somebody and the person gets sick? Radioactive decay. A person receives radiation treatment, for instance, and you need to know when it's safe for them to go home and be around other people. You would use a logarithm to figure that out. And then we also have the Richter scale for earthquakes. It's a logarithmic scale, which we'll talk about a little bit later on in the next unit, actually. And then also the decibel scale for sound intensity. for how loud a sound is. So again, some of those we'll talk about in the next unit when we talk about logarithms a little bit more. But just so you know, yes, they actually are used, not by every person, but they are very important for things like this. So I have good news for you. It's actually pretty easy to convert an exponential equation into a logarithmic one, even though you've never seen a log before. It's okay. So notice what happens. I'm going to get some color coding going here. Okay, so I have the base of my exponent, which becomes the base of my log, and this is a subscript, which you've probably seen in your chemistry classes. My exponent ends up on the other side of the equal sign, and my product, or my answer, for lack of a better term, on the exponent actually becomes the argument. It's called the argument of the logarithm. Soundy, soundy, sound. So let's do some examples. I'm going to show you how to convert and then how to put it into the calculator. So I've got example number 1 is our old one, 2 to the x equals 10. We're going to finally find out what that is. So exciting. We know it's going to be between 3 and 4 though. So I'm going to convert this into exponential form, from exponential form to logarithmic form, because it'll take this exponent.
Again, teachers, thank you for your help getting kids out of the building this afternoon. If you can still hear me, please go home. Enjoy your spring break. Bye-bye.
It's going to take that exponent and make it the answer, for lack of a better term. So I'm going to take my base, and that's going to become the base of the logarithm. So you write that like log. I don't know why it is blurring on me. And then subscript 2, so it's a little 2, kind of like if you think about like H2O, that kind of thing. It's a subscript, so that's the same thing. So it's small. And then your product, so the 10 becomes the argument, and you can put it in parentheses. And then that's going to equal your exponent. So it's converted, and now that awkwardly placed x, that awkwardly placed variable that I didn't know how to cancel it out in order to figure out its value, well, it's right here. So all you have to do is put this in the calculator, and then you got it. So you're going to go to a new calculator page on your Inspire, and you're going to press Control and then 10 to the x, and that will give you a logarithm. And then put base 2 of 10. So log base 2 of 10 is how you say that. And press enter, and that gives you 3.32193, and it would keep going. We're just going to round it to the nearest hundredth. So x is 3.32. You know what? Let's go one more digit. Let's go thousandths. 2. So that means that 2 to the power of 3.322 should be pretty close to 10. It's not going to be exactly because I did round it. But let's try it. 2 to the power of 3.322 is approximately 10, because again I did round my exponent. And that works. Yay! All right, let's try another one. 3 to the x power equals 243. So I'm going to convert. So my base of my exponent, the 3, becomes the base of my log. So log base 3 of, so the product becomes the argument of the log, 243, equals, and the exponent becomes the right-hand side of your equation. So log base 3 of 243 equals x. That's going to tell me what exponent I need. So Control 10 to the x, log base 3 of 243. So that means, oops, you can't even see what I did. That means 3 to the power of 5 equals 243. So check it. So 3 to the power of 5 3 to the 5th power does in fact equal 243. Yay, so it worked. The last one I want to do just on the video is number 5, e to the x. So e is, like I was saying, I think in the previous video, e is a special number kind of like pi. So it's got a value, and it's a value that is used when you're doing compound interest. When we talk about compound interest, should be next week or the week after. We're going to use e a lot. So it is in your control book menu, as I kind of like to call it, where all the symbols are. Pi, e, I, and then some other things. So if you just kind of stick it there, I'll give you the value. So it's approximately 2.71828, and then it keeps going. It's got its own special exponent button and its own special log button. So when you see ln, it stands for natural log. All that is log base e. So if I use that special button, so control natural log, and I put something there, I'm just going to put a random number there for now, okay? So if I put something there, that's the same as saying log base e of the same number gives you the same answer. So just kind of ignore that right now. So ln is just log base e. It's just a special button for it. It's a special kind of word for it. And it gets its own special word and its own special buttons because, like I said, it does get used a lot in finance for compound interest. So it merits its own button. It's so special. All right, so we're going to convert it. So I could say log base e of 2000 equals x. But remember, log base e gets its own kind of special way of writing it. So natural log of 2000 equals x. So put that in your calculator. So control e to the x is natural log. So natural log of 2000 equals 7.6009. And I was rounding to the third decimal place, the thousandth. So I'm going to put 7.601. And then just to check it, let me just show you. This means that e to the power of 7.601 should be about 2000. So let's check that. So e to the power of 7.601. So since I've rounded my exponent up a little bit, my answer's a little bit bigger, but that's okay. We did find the right solution, so we're pretty close. We're within rounding error. So it's about 2000. So we've got it right. All right, so we are going to do the rest of these as an example in class tomorrow. So thanks for watching, and I'll see you.